Today we're going to cover basic properties of logs and how to solve common logs. First property we're going to talk about is the product property. Product means multiplication, and what that tells us is that if two logs of the same base are being added, then we can multiply the insides of the logs, the 10 and the 100, and that comes together as one log of 1000. They go both directions. We can break them up or put them together. Here's a couple examples. Log base 5 of 50 and log base 5 of 62.5. First, notice that the bases are the same. They both have a base 5. Then the first thing I'm going to do is I'm going to multiply 5 times 62.5. When I multiply 50 times 62.5, I'm left with log base 5 of 3,125. Now, if I'm going to solve this, I can set it equal to x because that's what I'm trying to solve. Now I'm going to change it from log format to exponential format to make it easier to solve. When I do that, I have 5 to what power is equal to 3125. Now the easiest way of doing this is just multiply 5 times 5 times 5 times 5 times 5 in your calculator until you get 3125. And we figure out that 5 to the power of 5 is equal to 3125. My answer here is log base 5 of 3125 is equal to 5. Now for the second example on the right, we have log base 10. Remember, if there's no base written, we have a common log of 10. Log base 10 of 100 plus log base 10 of 1000. I'm going to rewrite it. That gives me log base 10 of 100,000. And if we think about it, 10 to what exponent is equal to 100,000? We'll just count the zeros. There's 1, 2, 3, 4, 5 zeros. So we know our answer again is equal to 5. Okay, two more examples. We have log base 3 of 3 plus log base 3 of 27. Now this one, there's two ways of doing it because I can easily see that log base 3 of 3, well, 3 to the power of 1 is equal to 3. So I know that log base 3 of 3 is 1. I can also see that 3 to the power of 3 is equal to 27. So log base 3 of 27 is simply equal to 3. There's a plus sign in the middle. So I can just add these up. 1 plus 3 is equal to 4. That's one fast, easy way of doing this. The other way of completing this would be the multiplication that we just did. 3 times 27 is 81. So 3 to what power is equal to 81? Well, we know that 3 to the 4th power is equal to 81. So another way of completing this is the multiplication. So notice there's two ways of doing this problem. Some problems are easier done one way, others are easier done another way. Now the one on the right, I could do it the easy way. I know that 8 to the power of 1/3 is equal to 2. But most times we're not going to think that with fractional exponents. So I'm not going to do it that way. Instead, what I'm going to do is I'm going to multiply those out. 2 times 32 is 64. Log base 8 of 64 is equal to what? Well, 8 to the power of x is equal to 64. What would my x be? We know that 8 squared is equal to 64. That means that log base 8 of 64 is simply equal to 2. So now we're doing the quotient property, which is the exact opposite of the product property. Here, if we are subtracting two logs with common base, then we simply divide the inside of the logs. Just that simple. So this is the opposite of what we were just doing. Here I have log base 4 of 320 minus log base 4 of 5. I divide those because of the subtraction sign. That gives me log base 4. 320 divided by 5 is 64. And we need to figure out what that equals. So we put it into exponential form. 4 to what power is equal to 64? Well, we know that 4 times 4 is 16 times another 4 is 64. So log base 4 of 64 is simply 3, because 4 to the third power is equal to 64. Here again we have bases of 10, so we say log base 10 of 5.4 divided by 0.054. That gives me log base 10 of, and when I divide those two numbers, I'm left with 100. Well, the base is 10, so we say 10 to what power is equal to 100. We know that 10 squared is 100, so my answer is 2. Two more examples here. We have log base 6 of 496.8 minus log base 6 of 2.3. Obviously, we're not going to do that in our heads, so we divide log base 6, and the two numbers get divided because of the subtraction sign. The subtraction sign doesn't tell you anything other than simply to divide these. I'm left with log base 6 of 216. Now we can solve this fairly easily. 6 to what power is equal to 216? Well, 6 times 6 is 36. 6 times another 6, 36, is 216. So that means that 6 cubed is equal to 216. That gives me a final answer of 3. Now the next one has both pluses and minuses. We follow our order of operations, and our order of operations tells us to move from left to right. So the first part we have is the plus sign. The plus sign tells us to multiply. That's going to be 4 times 6. And log base 8 of 4 times 6 is 24. Now there's a minus log base 8 of 3. So now we divide because of that subtraction sign. The subtraction sign tells us to divide. Well, 24 divided by 3 is 8. Then you ask yourself, 8 to what power is equal to 8? Well, I hope you see quite easily that 8 to the power of 1 is 8. So our answer is 1. Now, what if somebody puts exponents on your logs? It's called the power property of logs. These are really simple. All you do is you take that exponent that's on top of your log and you move it to the front. That's it. So you take that exponent that's on top of your log and you move it to the front. That's all you have to do. Now, granted, these can go back and forth. So here's my example down here. I have log base 8 of 8 to the power of 2. So what I do is I take that 2 and I move it to the front. And now I have 2 times log base 8 of 8. We just said that log base 8 of 8 is equal to 1, so that gives us 2 times 1, which is 2 as our answer. That's all you do. All right, let's take a look at another one. I have a 3 as an exponent. I'm going to take that 3 and I'm going to move it down. Now I can rewrite it. 3 times log base 7 of 49. Solve the log. 7 to what power is equal to 49? Well, 7 squared is equal to 49. So we know that log base 7 of 49, that right there is equal to 2. That gives us an answer of 3 times 2, which is equal to 6. 6 is our final answer. All right, let's try a couple more. First step, take that 4 and move it to the front. That gives me 4 times log base 2 of 0.5. Now we solve the log. Now this log is a little more tricky. So log base 2 of 0.5, that means 2 to what power is equal to 0.5, or 0.5 is the same as 1/2. So 2 to what power is equal to 1/2? Well, we should know that 2 to the power of a negative 1 exponent is equal to 1/2, because all we did was we took that 2 and we flipped it upside down. Negative exponents flip it upside down. That means we know that log base 2 of 0.5 is equal to negative 1. So that leaves us with 4 times negative 1 is equal to negative 4 as a final answer. So having an exponent on a log really isn't that difficult. Here's another subtraction problem. Now we have a couple options. We can change this log to log base 3 of 3 cubed, and that would be log base 3 of 27. Subtraction tells us to divide, and so what that would give us is log base 3 of 243 divided by 27. Well, 243 divided by 27 is 9. And we should know that 3 to the power of 2 is equal to 9, so our final answer there would be 2. Just that simple. That's one way of doing it. Here's another way of doing it. I'm going to solve the logs individually. So log base 3 of 243. That means 3 to what power is 243? We know that 3 to the 5th power is 243. So log base 3 of 243 is 5. Then you should know pretty simply that log base 3 of 3 is 1. So 3 log base 3 of 3. Well, log base 3 of 3 is 1. So 3 times 1 is equal to 3. If I did 5 log base 3 of 243 minus 3 log base 3 of 3, that equals 2. Two different ways giving you the same answer. Now, do I care which way you do it? No, of course not. Some people are going to think one way is easier than the other. Use whatever works best for you. Now, this throws people because of the square root. They think, hey, there's no exponents, but that's wrong. Remember, a square root is a fractional exponent. So the first thing you want to do whenever you have a root symbol is to change that into your fractional exponent. This is giving you log base b 2x, and that square root is on the whole thing, 1/2. So you have log base b of 2x to the power of 1/2. Now you take your 1/2 and you put it in front. That's giving you 1/2 in front, and you still have log base b of 2x. Now the 2 and the x, they're multiplying. They're not one number, they're actually multiplying. So what you do is you still need to break this apart. Because it's multiplying, when we break things apart, it becomes addition. And when we break it apart, we're left with 1/2 log base b of 2 plus 1/2 log base b of x. Some books are going to want the 1/2 factored out as a greatest common factor. However, most books are going to want it in this format. So the last problem took one log and split it into two. Here we're taking two logs and going to put them into one. Now we said that an exponent goes from the top down in front. Here we're doing the opposite. We have a number in front, so what it's going to do is climb up and become the exponent. I have this twice. That's going to give me log base 6 of 2 cubed plus log base 6 of 6 squared. Well, 2 cubed is 8, so log base 6 of 8 plus log base 6 of 6 squared is 36. The plus symbol there tells us to multiply the 8 and the 36, and that gives us a final answer of log base 6 of, and 8 times 36 is 288. All right, now here's a challenge problem. Write as a single logarithm. Assume that the variables represent positive numbers. So we start this by doing the same thing. If the number is in front of the log, it can climb up and become the exponent. The first one is going to be log base 5 x to the power of 3. Then it says minus, and the next one is an exponent of 1/3. So that goes on top there, giving us log base 5 x to the power of 1/3. And then the next one is a 2. It climbs on top of that x also, leaving a plus log base 5 of x squared. We know that adding is multiplication and that subtracting is division. Forget about the logs for a second and just look at what's happening inside them. We have x cubed divided by x to the 1/3 times x squared. Now if we remember, When we're multiplying like bases, we're going to add the exponents. So what we have is 3 minus 1/3 plus 2. Now we can just add and subtract like in elementary school. 3 plus 2 is 5 minus 1/3. The 5 is over an invisible 1. And I need common denominators in order to add and subtract. That means I need to multiply the bottom by 3, and whatever I do to the bottom, I do to the top. That gives me a common denominator of 3, and on top I have 15 minus 1. That's 14 over 3. The log base 5 hasn't changed. The x hasn't changed. What we've done is we've multiplied and divided. And that leaves us with an exponent of 14 over 3. All right, a couple more properties of logs that are going to make your life very easy. Now, the first one, hopefully you've already seen as a general property, because we've had this with log base 8 of 8. We've had it with log base 10 of 10. The first one is if you have a log base b of b, then they're going to cancel out, and whatever that exponent is, that is your final answer. So what am I saying? Well, if I take the 7 and put it in front like we're supposed to, I have log base 10 of 10. Log base 10 of 10 cancel each other out, just leaving me with that number. So if you look at our example here, number 11, it says log base 2 of 2, all raised, and it should be in parentheses, to the power of x over 2 plus 5. So what do? The exponent comes down in front, and that would give you x over 2 plus 5 times log base 2 of 2. Well, log base 2 of 2 cancels out, and that leaves you with a final answer of x over 2 plus 5. Just that simple. The other property, and this is very important later on when we're solving, is the opposite. If the log is in the exponent, the log is up there in the exponent, and the base of the log is the same as the base of the exponent, they just cancel out. So it's weird to see a log up in the exponent, but we're going to use this a lot when we're solving logs. So 10 to the power of log base 10. 10 to the power of log base 10. They just cancel out, and we're left with an answer of whatever was in the log. The 2 is in the log. So for our example here, 2.5 to the power of log base 2.5. Notice the base of the exponent and the base of the log are the same thing. That means they cancel out, and our answer is 19. No math involved. All right, the next property is change of base formula. The great thing about change of base formula is allows you to put all of these logs into your calculators because we're going to change the base. Now, that's not the only way of doing it, but let's be honest, that's how most people are going to do it. If you have a log with a random base, you can change it to a division problem and choose whatever base you want. So their example is log base 4 of 8. So they wanted to use 2 because they can figure things out with the 2. So they said log base 2 of 8 divided by log base 2 of 4. Because log base 2 of 8 is 3 and log base 2 of 4 is 2. There you go. They didn't need the calculator. And if you're not sure what I'm talking about, 2 cubed is equal to 8. And that's how they got the 3. And then 2 squared is equal to 4. And that's how they got the 2, 3 over 2. So if I have log base 8 of 32, there's 2 ways of doing it. I can do the same thing. Log base 2 of 32 divided by log base 2 of 8. Because I know that 2 to what power is 32? Well, 2 to the 5th power is 32. And I know that 2 to what power is 8? I know that 2 cubed is 8. So that would give me 5/3. So something that I couldn't have done because the answer was a fraction, I can do very easily in my head by just changing the base. Now, I mentioned calculators earlier. Well, your calculator has a common base of 10. So what you can do is just rewrite it. Log, I don't have to write the 10 down there, but you can if you want to, of 32 divided by log base 10 of 8. So remember, your calculator has a common log of 10 for a base. I can just plug this into my calculator, and my calculator gives me 1.66666 repeating. Well, guess what? That's the same as 5/3. Here's another one that's probably easier to do in our head than actually plug it into the calculator. I can use a change of base, and I would say log base 3 of 1/27 divided by log base 3 of 9. Now, why did I use base of 3? Because 3 goes into both 9 and 27. So then we ask ourselves, 3 to what power is equal to 27? Well, we know that 3 cubed is 27. Great, but it flipped upside down. And so what we do is we use a negative exponent. So 3 to the power of negative 3 is equal to 1/27. Then we ask ourselves, 3 to what power is equal to 9? Well, I know that 3 squared is equal to 9, so that's a 2, which gives me negative 3/2. Just that easy. If you wanted to plug it into a calculator, you totally could have done that. That would be log of 1/27 divided by log of 9. Plug that into your calculator, and it will give you an answer of negative 1.5, which is the same as negative 3/2. The reality of it is probably took you longer to type it into your calculator than to just solve it by hand. 2 more examples. Now these, notice I can't get a common number. Like the last one I could use 3 for a common base, or the one before it I could use 2 for a common base. These, I can't find a common base with 15 and 16. So these you want to use your common log of 10, and you would type in your calculator log 16 divided by log 15. You just type that right in your calculator, and you should get an answer of about 1.024. Same thing for the next one. You're just going to type in your calculator log 25 divided by log 12. Again, the common base here is 10. You don't have to write that because it's the common base. And that should give you an answer of around 1.295. So this common base change of base formula allows you to use a calculator when you normally couldn't.